This is example 1217. There's no numbers. This is done in terms of variables. And so it says find the radial and transverse. So first of all, in the R direction they're calling radial, and what I'm calling the theta direction they say is the transverse direction. So they want the radial and transverse components of the velocity and acceleration, and they say that this ride is going in a circle or a constant r. Okay, so why don't we start by writing down the velocity equation. So if you remember, the velocity equation is r dot is the velocity, okay, changing in the radial direction. And remember, the radius times the angular velocity is the velocity going around in a circle. So that's in u theta. And so the key thing is it's a constant r, so we know that r dot equals 0. We also know that r double dot equals 0. So in this case, we know that that's 0. So the velocity is going to just be r theta dot u theta. That makes sense. Just spinning in a circle with a speed of the angular velocity times the r. So now let's do the acceleration. So if you remember from the notes, you have this acceleration due to the radius increasing in speed going outwards, and then you have this centripetal acceleration, which was r theta dot squared, which is the same as v squared over r. Okay, and so that's going in the r direction, and then in the theta direction or the transverse direction, so we have r times theta double dots. Remember, the radius times the angular thing equals the translational thing. So radius times angular acceleration will equal the translational acceleration. And remember, we had this weird Coriolis acceleration, two of them, r dot, theta dot, in the theta direction. Well, r dot is 0 and r double dot is 0, so that one's 0 and that one's 0. So we end up with the acceleration is minus r theta dot squared, so the centripetal acceleration in the radial direction, and r theta double dot in the transverse direction. That's it.